Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session we're going to be talking about LDRs, which stand for light dependent resistors. So what are light dependent resistors? They are basically resistors which depend upon the light that arrives out them. So we'll start off with that. So light dependent resistors, they are resistors which depend upon the light intensity they receive. So if I change the amount of light in the room, the resistance of that device will change. Here is our circuit diagram. So notice it's still a resistor, which is the rectangle, but we've got two arrows to show you light is going into it. So this is the circuit symbol. So that's a light dependent resistor. Done. Right, so investigating light intensity and the resistance of an LDR. So if we connect it up into a circuit, let's go, we're over here. There we go. Here is the LDR, and we're going to put an ammeter in series with it, and we're going to put a voltmeter around it. Yeah, now if I change the light intensity in this room, so if I change the light intensity, so we change the light intensity. I don't know, maybe you bring a lamp closer towards it, and it increases the light intensity, or you move it away, it decreases the light intensity. That's one way you can change the amount of light that the LDR is going to receive. Now, if you were to change the light, so if we plot a graph, then, oh, hang on, here's our table of results. Light intensity, and we take values of the voltage and the current, and then we calculate the resistance by doing V divided by I. Yeah, so we change the light intensity, measure the voltage from the voltmeter, measure the current from the ammeter, then calculate the resistance using V divided by I. We can get the following graph: resistance against light intensity. What happens? As you increase the light intensity, you'll find that the resistance drops down. Tough times. Well, no, it's not tough times, it's great times. Okay, now, scrolling down. Actually, you need to memorize that graph. So as you increase the light intensity, the resistance drops down for the LDR. Scrolling down, test your understanding. What happens to the speed of the motor as the light intensity in the room decreases? So let's say we have the following circuit. We've got a power supply, we have an LDR, here's our LDR, and I have a motor. The motor is basically a fan that's going to spin. So as the room becomes darker, yes, light intensity is going to decrease. What's going to happen to the speed of the motor? Right, you know that if we've got resistance against light intensity, this is only for the LDR. Only for the LDR, it will drop down. So if I'm making the room darker, what's going to happen to the resistance? So if I make the light intensity decrease, the resistance will go up. Look at that graph. So as light intensity decreases, the resistance increases. Okay, so what does that mean to the rest of your circuit? If the resistance increases, therefore you know that the current will decrease. Yes, resistance increases, the current will drop down because it's harder for the current to flow around. Why? You've got a greater resistance. So therefore, the current decreases. Right, so what does that mean to the motor? The motor has less current going into it, therefore it will spin slower. So therefore, the motor will spin. I can't spell spin. Will spin slower. Nice stuff. Right, okay, so that is going to test your understanding. Make sure you understand that before we move on. Actually, no, I think we're on the summary. We're at the summary bit. So, summary. LDRs are resistors which depend upon the light intensity. They are used in many different concepts, but mainly for automatic street lighting. Why? Because as it changes from day to night, the electrical circuits change automatically. No one's there to turn a switch off and on. They are represented by the symbol, this one over here. Yes, as the temperature of the LDR increases, the resistance drops down according to this graph. So this is light intensity. And it's dropping down here. And that's it for today. I shall see you next time for another cool session in CeerazzleDazzle Physics. Goodbye.